Hello everybody and welcome to another episode of No Orientation Programming. I'm Joe and today we will continue our games server. More specifically the account creation stuff. Last time we have finished our authentication concept. We have written down all the cases we can have, and the result is quite a cool process that is in our game interacting process. One of our main processes, we can create a secure connection. With this secure connection, this is done over SSH. On top of this secure channel, we have the authenticating, the user. One moment. Yes, the user authorizing process. And the user authorizing process is using the SSH authentication layer, in which we get multiple authentication requests, like public key, password, or none. Depending on the authentication method, we start different other processes. And one of the cases is that a new user wants to enter the system and create an account. This is done with a special keyword as login username, for example create, and as soon as we get the authentication method none and see that the username is create, we can redirect the user to a special page, which is the account creation page. For this account creation page, we need widgets, and this was the last the position we have stopped. The point we have stopped, and I have prepared a little bit already. Yes, so some things are working already. We have a text box here. And this, we have two text boxes in which we can enter a text. Yes, so for example, if I press enter and then test, and then I press enter again, then I have this string in the text box already. I can go again, I can set the focus again and delete parts of the string, press enter, then the text has changed. And I can do something else. I can make a test string, press enter. And if I press enter, remove parts of the text and then I press escape, then the change then the text is not changed. So the change is aborted. So it's quite cool already. But as you may have noticed already, if I press multiple keys, then at some point this thing is freezing. It's not doing anything anymore. So we have to fix that. And I have a guess already. I think I know the reason. Let's see if I can. If I connect to the server, then let's see what is happening. If I press J, then we get encrypted packets, of course. That is from the client. I get a very small packet which contains the letter H, J. I've pressed J and the answer from the server is a complete frame, encrypted. And if I press multiple keys, then you can see that multiple packets are sent and received. But at some point, the server seems to be frozen. Yes, this is the point. I press J and K and nothing is happening anymore. But in fact, it's the client who is not sending anymore. It's not the server which is stuck. Hey, what is happening? But I think it's the client. As you can see, I can connect to the debugging server still, and I think I can connect. Oh, come on. Let's try to connect via telnet, localhost 4000. As you can see, the server is still responding. And we see this in the process tree as well. So why is the client not sending anymore? And I think this is because we have still some little work to do. This is the first thing we will do today. I think it is, yes, it's this RFC, the Secure Shell Connection Protocol. This protocol, this layer, which is on top of the transport layer, has a special feature, and this feature is called flow control. If we send to the If we send multiple frames to the client, then the client occasionally sends a packet through the channel, and this packet is called window adjustment. That is the data window, and if we send a frame to the client, then multiple times on sometimes the client sends a window adjust. We should see this in the log, I think. It should be called window adjust. Yes, I have seen this packet already, but we have to send more frames, and at the moment we don't have the ability to send more frames. I have seen this packet because at first we had an animation in the frame, and we were sending a frame every 1 second, and then after 2 minutes or so I saw this packet, and this packet means that we are allowed to send more data, and as a server we have to send this packet as well, but at the moment we don't. So let's verify this. Remote win size. At some point during the as soon as an channel is opened, we send a packet, the packet size, remote packet size. We send our local channel number and yes, win size init. Yes, that's it. We have limited our data window to just 32 bytes. The client is allowed to only send 32 bytes. And now let's try to send even less bytes, like 7. Then we should have this behavior earlier. Let's count the bytes. 1, 2, 3, 4, 5, 6, 7, and that's it. 7. It was exactly 7. So let's try again. 1, 2, 3, 4, 5, 6, 7, and then an 8. Okay, cool. Now let's make the opposite test. 1000. Yes, I think this is it. Yes, that's now we have received a window adjust packet from the client. We have sent a lot of frames, and the client tells us we can send additional 50 kilobytes. So it's quite a lot. But I want the server to be very strict. So it seems to be limitless at the moment, but that's fine. I want to have a very small window. That's fine. And I want to have a local window size. Remaining. Yes, fine for me. And we should set this variable to our init value, and I want this information to be printed. And for this we have a function that is called progress string. It's defined somewhere here. P buffer and P buff and let's see if we can compile this. So yes, perfect. Perfect. Now I see the window size we have, and if I press if I enter the keys, then we have to adjust this value. Ooh. And this value needs to be adjusted somewhere. We have multiple possible packets to pass. That is, for example, it can be SSH message channel window adjust. SSH message channel window adjust, and here we can see the window size specification. The window size specifies how many bytes the other party can send before it must wait. So the client is waiting for us to send the permission. So the client can send multiple bytes, additional bytes. Bytes to add. After receiving this message, the recipient may send the given number of bytes more than it was previously allowed to send. The window size is incremented. Implementations must correctly handle window sizes of up to this. The window must not be increased above these many bytes. The data transfer is done with messages of the following type. Data transfer. The maximum amount of data allowed is determined by the maximum packet size for the channel and the current window size, whichever is smaller. The window size is decremented by the amount of data sent. Both parties may ignore all extra data sent after the allowed window is empty. So a client could ignore the window size and send data, and we as a server are allowed to ignore data. So let's see. This packet should not change the window size, I think. Yes, for example, this messages like this. Message channel end of file. This message does not consume window space and can be sent even if no window space is available. Channel close does not consume window space and can be sent even if no window space is available. So we have exceptions. A channel request does not consume window space. A channel success and failure does not consume window space. With these messages, this message too. I'm not sure. Ah, that's bad. We have to know. We have to know. That's bad. Okay. If we do not have any channel data, return 0. If there is an error, return 0. Otherwise, we have received data and we have to adjust the window size. And that is window size, local win remaining. U in 32 type. Bound win. No, lower bound of the window is equal to the half, or let's see. Uh, 7 shifted by 2 is 1. If this is nope. Oh, this was the wrong. Yes, that's it. If the local window, the remaining window, is bigger than the lower bound, then return. Do nothing. Otherwise, And we have to decrement. We have to decrement our window, that is this. Let's see. The maximum amount of data allowed is determined by the maximum packet size for the channel and the current window size, whichever is smaller. The window size is decremented by the amount of data sent. The size of this string. Okay. If the local window, yes, just let's see if now we should see that decrement. We can press 2 keys, the first one, now again, and now we should not be able to get anything, and that's true. That's fine. So now we can check. Now we can send our data. That is the window adjust, and this is the recipient channel. We want to send a packet. Let's send. Let's use this. Okay, we have a vector message and we reserve something. Then we add a len and a byte. Then we add something. Yes, window adjust. That's in the filtering. We have a passing function. Okay. Len add is remote number channel. Byte add. This is a byte, and then we have a len length. Recipient channel, yes. And the bytes to add is the initial window size. Oh, I have to be careful. Bytes to add. This is another len add to the message. Window adjust. From client. From server. Bytes to add. Always the same. Okay, let's see. Now, let's test it. Press 1, 2, 3, 4, 5, 6. Window adjust from server. And that's not perfect, because now we have to increment. Bytes to add is equal to this. Win size init. Bytes to add, bytes to add, bytes to add. Now we connect 1, 2, 3, 4, 5, 6. That's perfect. And now can I send? Yes. That's cool. In fact, this is very cool. This is very cool. Now we tell the client that we only want to get 7 bytes. You can see sometimes we get the message because I have the verbose mode on. Oh no, it gets overwritten all the time, but this is fine. Cool, cool, cool. Now we could increase this thing to 32, for example. Now we should get fewer messages. Perfect. That's cool. That's perfect. So now the window size should be just 7. It's fine enough. Good enough. No, it's too hardcore. Let's make it. Very cool. Okay. Cool, cool, cool. Implement window adjustment from server to client. Very cool. So now we want to get 2 things done two things need to be done in the filtering, SSH filtering. That is, we support the navigation. If we say my text box, enter. If I press enter, then I can navigate in the text and I can delete a character at any position. But as soon as I press delete, then we get an unexpected packet. We did not implement this yet, so this is it. I'm thinking about implementing a state machine for these sequences. I think 1B is the escape sequence. The escape character. Let's see. And the escape code. So what's that? 1B is escape. Yes, that's escape. Then we have 5B. 5B is this. Then we have this, I think. This is a color. Perfect. So, VT sequences and xterm sequences. Up, down, left, right. Yes. At the moment, I have implemented the stuff like this, and that's very bad. Key is user disconnect. What does this function do? Lib gaming. Key control C. Key get, key data process. I think that's fine. Then we have a state machine. Key state. Hi, Banana Bear. We have implemented a cool feature already. Key state. Oh no. State key. Fine. Yes, I think this is fine, hopefully. Can I compile this thing? Come on. No return statement. The server is adjusting the data window size now. That's very cool. So we can see that we have a window size of 100 and we have a window size of 128, and if we press keys, then this window size is decreasing. And if we press enough keys, then we get a window adjust from the client. This was from the client. And if we have reached a lower bound, then the server is sending the same message to the client, telling the client that additional 128 bits are allowed to be sent. And this is the initial window size, and this is the current window size. So that's quite cool. Otherwise, the client is very polite and doesn't send any bytes anymore. So this is very cool. Now we have a state machine, the key state machine, and this state machine. Data process. Here we have a case. I don't want to write the case anymore. Case switch. State is key state string of state key. Same as always. Fine. So we execute this function. So this is key escape. Key escape, yes. Escaped. If and we will add an uint 8 byte for b for byte. If b is equal to key escape, then m state key is equal to key escaped break. Otherwise, we let's call it key. If key is user disconnect, then filter d init. Key received. Huh? I think this is fine. So we can remove this and this. We can remove this. Key get. Oh, come on, what is key get? Why is key get returning something? Oh, please do not. Oh, okay. Oh, come on. I think I will switch. I will switch this. The meaning. Oh, okay, okay. Key get. Data byte, whatever. No, just key. We will use this function instead. Success is equal to data process. If success not equal to positive, could not process data. So this function is called data process. Now here we return pending. Could not fetch channel data. If not, Now here we can return an error. Here as well. So if we don't have any channel data, then we can return pending. If we get an error, then we can return error, and on the high level state machine we deinitialize the filter. Now let's see. Escaped. So we have an escape sequence, and let's call it escape 1 and escape 2. If key is equal to, okay, let's see, this is the key get function, and this key get function gets executed No, that's not cool. That's not cool. Hmm. If not positive. Ooh, no, no, no. Ooh. That's not allowed. I want the filter to be deinitialized if there is an error. And I want to break if the function has processed the packet. Mm-hmm. Ah, okay. Yes, that's fine for me. So let's see. Come on. Data process. If we have an error, then deinitialize the filter. Fine. Pending, okay. Deinitialize 3 times. Yes. If we have received let's see. If success not equal to positive, then deinitialize. If success is equal to pending, continue. If it's not positive, go out. If it has finished processing the data, then break and return positive. Okay. So now we just have to if key is equal to this thing, then go to escape to, and then what is 41? 41 is A. So this is all the fancy stuff. Up, down, right, left. Ah, okay. And delete was this. It was longer than up, down, left, right. Ah, okay. So this is this. I understand. Okay. Ah. Now I have a strange idea. Ah, come on. I could. Ooh, this would change a lot. I could make the keys 16-bit wide, but I want to keep it for a moment. So. If I want an escape 3 state as well. If the key is equal to A, then commit key up. If B again a little bit macro magic. Let's make macro magic. Define the key check and commit, key for K for key and S for ST for state. I want to write this complete block as A. If I get A, then commit key up. I like to do perverted stuff like that. Not ST, but not ST. Okay, I can remove this and I can use this multiple times. For example, B is key down, C is key right, D is key left. And is interesting, and we need a key and. I have mapped these keys to the extended ASCII codes because I will never use something like this or this. So let's call it I may use this, but not this. So I have this key mapped. This may be a fatal error, but let's try out. Let's try to make some very bad code. 6 is key and, so we can say if we get an F, then we have key and. If we have the same as who? Oh, that's bad. That's bad. Should we support the F functions, the function keys? Yes, of course. Oh, I think I have to change all the key stuff. This is completely crazy. Okay, let's do it. Oh, I'm changing everything now. Key 16. Oh, int 16 type key 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 key. Now I can map key up the all special key stuff to something different. I don't know if this is a good idea. Key backspace. Key backspace. I don't know if this is a good idea. 1000. 1, 2, 3, 4. Let's compile and see all the bad stuff happening. Unused variable key filtering key. Key check and commit. Let's call this xterm check and commit. And this is called VT check and commit. No. This is quite hard, I think. This will be quite fancy. So we will call this state escape main. Then we will bracket, square bracket, bracket, That's fine. Now, do we have an escape 3? No, we can't. Yes, escape 3 is fine. That's the reason why escape 1, 2, 3. And escape tilde. Okay. So xterm check and commit. I want to support all of these at once. So we can use these. We can check these. Keypad 5. Keypad 5. Why keypad 5? Okay. And home should be supported. And home. Yes. Transfer filtering. Yes. The pipe now has to be at 16-bit wide, and now we will get a lot of errors, I guess. We have commit is the key main. Main, if we receive an escape sequence, then we go to the escape main. If we get a user disconnect, then we can break and go to the filter deinitialization. Otherwise, we just commit the key. If in this case the key is an 8-bit thing. Okay, that's fine. So we support A, B, C, D, then F and H, home. That's the xterm check and commit function. Now now we can have the key. That's so crazy. Key insert enum key extensions Mm-hmm. Mm-hmm. That is up, down, right, left, home and insert, delete. Let's make the same order. Home, insert, and page up, page down. Okay. We have home multiple times and multiple times, and then we have the F functions. Key F0 to 1, 2, 3, 4, 5, 6, 7, 8. Nine, 10, 16, 17, 18, 19, 20. 20. 1, 2, 3, 4, 5. Let's make this more compact. Nope. Mm-hmm. Fine. So we can say, if we get one of these, we can set the key immediately, and we have to set the mState key to as the key main. The parsing is finished at this point. And we can commit the key. Okay, then if key is equal to 1, then we have to say mState key is equal to escape 1. Uh-huh. Yes, that's fine. I call this byte check and commit. And key commit. This is so dirty. And I love it. That's so cool. So, if I have an escape sequence of 1 and I get the tilde, I don't think I need this anymore. No, we need this. Okay. So I can get a 1 and then I can get a tilde. And then I have to set key home. If I get this for 2, then I have to set key insert. If I get this for 3, then key delete. So we can have key delete multiple times. I guess we received a key. Nope. Mm-hmm. 1, 2, 3. Now. For 1 we can get 0, 1, 2, 3, 4, 5, 6, 7. What the hell? Why? Oh god, no. That's so bad. We have. Why do we have an empty space here? Ah, come on. Okay. If we are in state 1, then we can say if key is greater and equal to 0 and key is smaller and equal to 5, then break state key is equal to tilde. If key is not equal to tilde, then return Otherwise, state key is equal to st key main. In this case, we commit the key F0 plus key if the key is in between seven and 17 and 19. So between 7 and 9. Then we commit key F6 plus key minus 7. The same thing for 2, that is, if it is between 20 and 21, then commit key F9 plus key just plus key. Yes. And if it is between 3 and 6, we will reuse this code. We will extract this state machine to somewhere else because we have 700 lines of code. That's very bad, but that's just for testing now. 3 and 6, then commit F11 plus key minus 3. Eight and 9. Commit 15. Here. And we go to escape tilde every time. That's fine. Now let's see. If we have in 3 escape sequence 3, if we are in between 1 and 4. Commit F17. And in this case, if we get one of these, the escape 1. If key is equal to P, then commit key F1 and go to key main. PQRST. We can, if it's bigger than P and smaller than S, PQRS. Then we have F1 plus key minus P and key main. We have to remove this. What should we do here? Unexpected key. Received unexpected key. Unexpected key in state. Key main. Okay. Oh no. Oh. Yes, game selected. Now it's pipe. Now we have. We need a type def. Type def int 16 user. Key user. Now I have created a construction site. So bad, but we have to do it. Yes, key user. Game interacting. So, user onboarding. I hope this is working later on. In the fish was not declared in the scope. Byte check key commit key delete. Key delete should be, why not, insert delete. Home paging. Register paging. Okay. Guest introducing. Okay. What if I press L? Oh! Okay. Interesting. What if I press G? H? A, B, C? What if I press Enter? Whoa. J? What if I press down? Unexpected key in state escape main. Yes. Okay, we got. Oh, yes. No, what? One moment. It's working quite fine already. So what if I press down? Then I must be in the key state key escape main. No, I should not be in this state. That's a stupid formatting. I press down. If I press down, then I have received data. The filtering receive data now. Received channel data. So yes, that's fine. That's fine. If I press down, then the transferring process says received data. That's the whole SSH packet decrypted. The decrypted SSH packet. We see we have received a string with length 3, a 1B, 5B, and 42. This thing, and now the filtering process is telling us we have received the channel data. So more specifically, and of course size 3, and that's the content of the channel data. That's fine. Now we have 1B. Now we have to check this. Yes, escape main if key is equal to received key 1B. Yes, and because we are in 1B, why is, I think this is executed only one time. Why? Because we pending. Yes, of course, pending. And here we have to say if we have committed something, then we say return positive. That's what we have to do. Every time we commit something, then we return positive. Pending, yes. Positive, positive, positive. Escape, escape. Error. Commit. Return. Nope. And tilde. Oh, I have forgotten to return positive. Every time we go to the main, we have to return positive. Okay, let's see. Main. If we set main here, then we have to return positive. Positive. Fine. Let's see how this is working. So if I press down, then I'm in ST. Ah, okay, that's cool. ST key main. Yes. Key get. B. B is down. Who is processing? The onboarding process. Key. Account create menu. We try to get the key from the pipe, from the filter pipe. At which point am I checking what? Down. User onboarding. What is this working? J and key is working. Why? I don't get it. User onboarding. I don't see at which point I'm processing. Ah, widget. No. Is the board is accept? This is fine, but key is down. User authorizing. No. Gamer interacting. No. Filtering. Onboarding. Come on. How is this possible? If I press J, then the cursor is going down because... Yes, because... we are processing. Yes. This is a list index. We have the key is processed in this function. All the widgets are stored in a list, and we have a list index object bound to the widgets. So we need to check our list index key process function. If key is down, fine. We have to print got menu key. Oh, yes. I think I know the problem. Ooh. Okay. Key user. And here we need lib gaming. Oh, yes, yes, yes. Has not been declared. Now I have a cyclic reference. Let's make a CPP class. No, CPP file key user. With just the type name for a moment. If I press down, yes, now this is working because the list index takes a 16-bit wide. As you can see, the window is going down much faster because we are consuming 3 bytes at a time. Now we can enter text on my text. Oh, cool. Now I have to send adjust. Okay. When I press enter is working as well. What if I press left? Left is not working. Left is not working because any widget has to include the key user This is a pure virtual function. This means the text box has key user. I think this is it. My text. Now left and right is working again. Enter, okay. What did happen? Unexpected key. Receive channel data. I should, yes, I should. For now, I should enable this thing. Oh, hopefully I can mine text. Ah, damn it. Okay, escape and enter. If I press escape main. Oh. What? Why? What? Received key. If I press escape. Oh. Okay. That's interesting. Escape itself is just escape. Okay, that's a special thing. If as the string that size is equal to 1 and p key is equal to key escape, then turn positive, then we just commit the escape key. Okay, that's fine. If I press my text, press enter, I go, now I press delete. Cool. So, and that's one step. We got one step further because now the channel is not cut down by the server because we were able to pass the delete escape sequence, and that's this one, escape 5b 33 7e. That's this sequence. We got this sequence, and now finally we can implement the delete function in the text box widget. This was a long road. We will extract this code to the filtering, transfer filtering. Yes, I think. Oh, lib gaming. Why are we using lib gaming at this point? I think we could The transfer filtering, yes, is a key filtering. I think the type def, this is just a temporary file, and I think the define goes into the transfer filtering. And the rest of the code maybe as well. Yes, and we can split the lib gaming file as well. I have to decide later. Okay, text box. Key process. Key is backspace. Key is left, right is common. If key is backspace. Okay, if key is equal to key delete, then if the cursor, the absolute cursor is equal, smaller or equal to size -1. Smaller is not good. Just equal. Otherwise, we remove the immediate decrement work size. Yes, I think this is it. If this is working, then it's beer time. Yes, of course. We need a double thing. So, my text, enter, press delete. Ooh. Not exactly what I wanted. I don't want this to happen. So I don't want a decrement of the cursor from this position to the left position. So let's press enter, my text. I want to delete E and I want to stay at E. If I press escape, then nothing has changed. If I press delete and enter, it has changed. If I press enter, fine. If I press enter now, okay. What if I press enter here? Nothing is changing. A, B, C, D. Channel 0 receive adjust, that's cool. But now let's test something. Test dot text, and let's try to open this in a file in Vim, ABCD. What if I press delete? Okay, nothing is happening if I'm at the end. Okay, then it's behaving the same. If I press that's cool. What if I press a special character like this? Okay, now I have received something strange. 2 signs. It's a German letter. Ooh. Okay. It's kind of working, but not really. This sequence, C3. Oh, come on. C3. C3. That's a Unicode character, I think. Something like that. Oh, come on. Mm-hmm. Extended ASCII characters. Like this, for example. 148. B, C, C, yes. What's C3? Oh, come on. Here we have the hex code and here we don't. Extended, and here we don't have either. Okay. Extended ASCII code. Come on, why? Yeah, that's better. And okay, I give up. Programming mode, decimal. I have typed in this character 148 is 94. We do not have 94 here. This is, I think, it's not an ASCII thing. Mm-hmm. called diaresis. What are those 2 bytes? I say I have received C3, fine, but what's B6? Why didn't we get the second key? Like, what is happening? What is a C3? C3 is 190. This does not make sense to me. I don't understand why channel data is len 2. Then I should get this message 2 times. Ah, no, yes, I know, no, just 1 time. Ah, that's so bad. We do not want to break at this point. We want to consume the whole data, yes. Now I have received 2. C3 and B6, that's fine. I was confused by this break. C3 and B6 does not make sense. Whatever, I'm receiving this thing. Oh, come on, why? This looked so nice. Okay, whatever. I don't need these characters. I do not care. Hopefully. So. Yes, cool. We can press up and down. What if we press F1? That's a bad idea. What if I... No, I don't want to press the function buttons. What can we press for testing? Page up and page down. Ah, that's interesting. Page up and down. And home. Yes, we will implement and home in the text box. That's cool, yes. If key is equal to key home, then one moment. Please. Bool, yes, that's cool. Decrement. Decrement if something has changed then return true. If not, then false. This is very important because here we have to return decrement, and here we have to return increment. If key is common, then something has changed. If not full, of course. If we are moving the cursor, then something has changed. If we are not in focus, we can't do anything. We have to be in the focus. If backspace false and true, if we can't delete something, then false. If we can't delete something here, false, otherwise true, fine. If key home, we have a reset function. Oh, come on. And this should be bool too. Ah. What if we press G? Ah, changed, yes. Ha 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 ha, okay. Ooh. Interesting. Interesting. Oh yes, we can optimize the class. We can optimize the class. Bool. Yes. Reset. Cursor and set. Lower G. We say changed. Reset. Changed. Bool. Changed. Yes. We reset the stuff and we return changed. Yes. Because now we can just return reset. We try to reset. We will reset in any case. And we return true if something has changed in the list index file. That's cool. That's cool. That's perfect. And I think that this code is the same for end reached, cursor and set. Let's see. Do we have this line? Yes. Changed can be is new. The cursor hard bound. Hard you bound. That's fine. This we have this line, we have this line a little bit different. But almost equal. We are not changing the offset. If okay, let's see, changed. No, we need this. Yes, fine. If we jump, we make multiple decrements or increments. We can say the same. Oh, we have to be careful. This is not allowed to use a function like this. Because if we want to disable the up and down, then okay, yes, we have. We no, it's fine. We can disable. Okay, we can disable the function itself by disabling the single character. That's okay. Why if we press G? Only in the case if size is bigger to Windows size. Okay, this is an extension. So we can just use this function. I think this is fine. So we have simplified the class. That's cool. Return this thing. Now we add 2 more functions. Key is home. Key is and key is up jump, down jump. Key is home if key is home. Key is home if key is equal to G or key is equal to key home. Then return true, otherwise return false. Key and quite similar. Key is and if it's a capital G and key is and. The list index is if key is home then reset, if key is, and then go cursor end set. So if I'm always closing the stuff before I need it. We have 33 minutes left. If up, if key is equal to capital key, or key is equal to key page up, return true, otherwise return false. Key jump down is capital J or key page down. Unused variable key index hard U bound. No declaration matches. Reset. This is important. This is an important line because now the list index class supports a variable size. This was not the case before. We are using the U-bound here. We are using the cursor absolute function here. So we are not allowed to change the cursor before this line. And now everything should work completely perfect. If I press capital G, I'm at the end. If I press G, I'm at the beginning. If I press AND, I'm at the end. If I press home, I am at home. Okay, now I press enter. My text, enter. If I press enter and press home, yes, of course, because this is the text box. Key delete. Return. Yes, of course, reset. And if I press key and then that's the navigation. Is this a word? Yeah. Deletion. And then These are the three main components of the text box key processing. So, my text, press enter again, page 1, oh, oh, come on, this is amazing. This took quite some time. Oh, the beer is absolutely ready. It's amazing. Okay, press enter. If I press multiple, what if I press capital, no, capital K is fine because it's a common character. What if I press G? Now. Is it okay if I make key page up? Can I do something like this? Key process K. Does this make sense? Because I do not have a jump function. I should use the jump function at this point. Yes, okay. Inc jump, decrement jump. This is the decrement. No, the increment. Yes, the increment. Changed, false, remove this, remove this, remove this. And decrement. I think this is fine because now I can say just return this function. I can remove this variable and these lines. I can use the function is key is down. This is strange. This was strange. Key is down increment. Key is is down jump. Yes. Increment jump, return increment jump. And here we have return decrement. Yes, this was very strange. Decrement, and now we have is up jump, decrement. Oh, come on. A decrement jump. And remove this thing. Yes, that's way better. Increment, decrement. Down, up. Increment, jump, down, jump. Yes. Yes. Oh, this class is getting better and better. Cool. What if I press page up? No, this was home and end. Page up. Oh, unexpected key in state. Okay, let's see why. We are very close, very close. Page, I pressed page up, I think. Yes, I'm escaping now. Then this. I'm in this state key main. And receive. Let's change the position of these two. That's confusing otherwise. So I press my text and the page up. I'm in the state key main. I have received this. Is this at least fine? 1B is the escape sequence. Then I got this thing. Then I got a 5. That's fine. Escape bracket. Unexpected key 5 in state escape bracket. Escape main. Yes, this is strange because in the escape main, if I get this thing, escape bracket, yes. And I'm in escape bracket, and if I'm in between, oh yes. I have implemented key home in escape 1, key home, then I have insert, then I have delete. And because I can't have 4, 5, 6, 7, 8 for the function buttons, I have to implement these two here. These couple of things here. Okay. key commit for is key and okay. 5 is key key main and oh no. Escape tilde. Be very careful, this is bad. This is better. Okay, key main. It's not the end of the parsing, but we got the key. In this case, we got key page up. If we get a 6, then we have key page down. And we want the tilde at the end. And home and end is again, if we have a different terminal, then key home. And 8. We do not have 9. Okay, that's fine. Home and end. So we can have end with 4 and 8. Keypad 5. Let's try if we can execute this keypad 5. No, it's just 5. Keypad 5. Okay, so let's see my text. Oh yeah. Oh, that's so cool. Oh yeah. That's so cool. Fine, perfect. Blah. I think now we have full control. If I press page down here, it's working as well. Now everything is very clean. This class, the size of this class is fine. That's okay. Oh, this is way better now. Increment, this is a very special function. And decrement. These are the main functions of the class, the main logic. It's very universal and fine. We should rearrange the functions because it's not reset cursor print reset increment decrement increment decrement increment jump decrement jump cursor offset key process Uh-huh. Now what? Yes. What if I press? What if I press bang? Yes, I have pressed shift and down. Let's do it again. I press shift and down. What do I get? I get channel data. We could remove this thing. Okay. We have got 6 bytes. Why 6 bytes? I've got, this is one, this is some shift. Ooh, yes, if I have one and then I have this sign. If I have this sign in the state, escape one unexpected key, yes. And this is where the fun begins. Because I want to support this as well. But it's not that hard, because that's the reason why I have made this. Because in the end this will be a class. A key can be have a modifier. Let's see something else. What is happening if I press shift and enter? Oh, that's bad. That's bad. This is unexpected. Shift. Oh, that's bad. Oh, come on. I thought that I have the same behavior if I press shift and enter, that I get something like this. Shift and down is now we have a modification. 2B. 2B, what's 1 and then 2B. 2B. Let's do this again. What is down? Down is this, B, just B, yes, B, and if I press Shift and down, then I have, instead of this sequence, I have this sequence. So we get escaped once and then I get this thing. But 1, 2, 3, 4, 5, 6. 6 bytes. We get 6 bytes. This escaping stuff is bad. To be. Okay, we can ignore this at the moment, but the real bad thing is that Shift and Enter is not working, because this can be used in, this could have been used in the lobbying process. If I have a multi-line text box and I press Shift Enter, I would expect to not send the text but just make a new line. So we can't distinguish these two types of enter keys. Oh. Why? Why? Oh, what's that? C0 and C1 codes. This is like what we get here. What am I printing here? Okay. We get one escaped and then it looks like something like this. Something like this. Okay, whatever. I think it's fine for the moment. What did I press? Oh yes, that's bad. If I press L. Yes. If I press L, then this key is a common key. That means we need to process this in a priority. We have different priority for addition, deletion, and navigation. but I think this is fine. This should not be the problem. I think this is key widgets. If I press L, what is happening? A, B, C, L. L is an accept key. Accept key is this index widgets key process. This is at this point. Yes. The widgets. Yes, this key process. That's it. For me, this is fine because here we have the special keys, and after that we try to get the common keys. That's okay. But we have to process the text box first, and only then we can okay. So the textbooks, the check for the textbooks, if it's in focus, has a higher priority than the check in the user onboarding process. Okay, that makes sense. To me at least. This is the textbooks. We have to check the textbooks. If the key is an L, the key is also a key accept, because L is key accept. But if the textbooks is focused and the textbooks is processing the letter L, then we are breaking at this point. So this is fine. Okay. I think we have finalized the widget stuff. That's cool. The filtering process is very important. That's a very important thing. So I think this is cool. This is a cool point to break. I'm quite satisfied with the outcome because it's quite stable. Resources, history. Support for navigation. Arrow up, down, left, right, home and end, page up and down. Arrow keys. Home and page up and down. Support delete key. And oh, come on, stop. At SSH window add SSH window adjustment. That's it. And now if we connect with telnet localhost, then we should check if we hopefully we did not destroy the list index class, so we have to test the other stuff. This is the first list, up and down, G and capital G, capital K, capital G, page up. No, this is not supported for, this is not supported for telnet at the moment. So this is fine. Okay. Menu navigation is fine too. Version history. Capital K and G is page up and page down. And in the version history document, this means to jump to the next version. Press capital G, capital and lowercase g. Yes. So this is working. Licenses. Yes, this seems to be fine. That's very cool. That's very cool. This list index class is used in so many situations now, and it's working so fine. I have I have split two things. Split. Trennen. I separated two things. The first one is the logic of a list element and the data of the list element. So I can use whatever kind of data and have the same logic. Like in this case, I have a text box is the same as a list of characters. So I can navigate through this list of characters. We should be able to... Oh. Okay, now we have to test something. If I add this, it's behaving like a normal list, that's fine. But what if I remove a letter now? So cool. It's quite cool, but but should I print an indicator at this point? An overflow indicator like in a normal list, like here. Like In the version history, we have these indicators that the document is longer than we can see, and if I'm at the end, the indicator is visible or not. I can think about it. We have the functionality. This list index class can... I think I can remove all this debugging stuff now. Hopefully. This is the same. And this is the same as well, I think. If size is smaller than the window. Now this is different. If the window is smaller or equal than the size. This is different. Let's see. If I have an offset and the offset plus that's the special resizing thing. Resize if necessary. So hopefully this thing is working still. Okay, that's cool. I don't want to use lower or equal. I want to say isn't this the same? No. It's not the same. I'm finished for today. If the window size is smaller or equal than the size, then the size is bigger than the window. Bigger or equal. Never change a running system. It's fine. It's fine. Okay. So this is fine. At first, when I had set the size, and then I have reset the list index, but that is bad because then, or if I set the window size, we should not, if we set the window size, then we should not reset the cursors. This was the case before. That's fine, that's cool. Text box, user onboarding, authorizing, okay. Filtering. The filtering is doing a lot of stuff now. We have to make this file smaller. It's the biggest file in the project and it's way too big. The file should have between 300 and 500 lines, so we can have two 500 lines files, big files. So let's see, somehow we have to remove all the stuff. The key get function, this. How long is this function? 600, 800, 200 lines. That's too big. Data process. Yes, it's also passing the subsystem. It's doing all the channel request stuff. The window adjustment, the window change, the putty window adjustment. It's doing a lot of stuff, yes. Doing a lot of parsing. Interesting, okay. Key get. We can set this 0 for a moment and we can a window adjust putty. We do not want to have this window change. What's that? Hello send. We don't need this. Let's keep this. Success channel request success send. We don't need this anymore. Subsystem. Received channel data. Cool. So, raiding somebody. Now it's beer time. Oh, gross. unstrukturierter als sonst. The big class is almost finished with his what's this? VHDL is above C++. I'm sorry. Let's rate gyros. Waveforms are very cool. See you next time on Thursday, theoretically. Bye. Next time we have an account, hopefully.